Hello, my name is Matt Heaney. I'm coming at you from a very dark and rainy evening in Nottingham, right in the middle of England. And welcome to my talk, Green Ticks, an introduction to Swift testing. In this talk, we'll take a look at Swift testing, the brand new testing framework available in Xcode 16. Before we jump into it, I want to quickly say thank you to iOSDevHappyHour and all the organizers behind this great event for having me, and a huge congratulations on 4 years. That's a huge deal. Also, thank you to everyone for spending about 15 minutes of your Saturday listening to my talk. I really hope you find it useful. For anyone I have not met yet, let me quickly introduce myself. As I mentioned, I'm Matt. I look like this on social media, and I'm a senior iOS developer. For the last couple of years, I've focused on contracting work and trying to break into that indie world, all under my brand of Hacked Reality Studio. One of the big things I did want to mention as part of this talk is that I'm a self-taught developer. And I learned how to make apps from YouTube videos, blogs, and a lot of Googling. I Googled how to make an iPhone app way back in 2012, and I guess I just never really stopped Googling it. I know a lot of people in the audience here are teaching themselves how to code or teaching themselves some new frameworks. And to those people, I just want to say, trust me, it's all worth it. Keep going. You got this. One of my favorite things about my career right now is I get to go to conferences all over the world. I was lucky enough to land a golden ticket to WWDC in June to be there in person for Apple's biggest development announcements. Honestly, I've not stopped talking about DubDub since I got back. Being there at Apple Park during the DubDub keynote is like nothing else. It's a day full of awesome tech chats, exploring the campus, and learning some hugely important things like the fact that Chris has awesome merch shirts and that Apple really doesn't have enough chairs when it comes to lunchtime. But of course, mixed in with all the fun, there were the big announcements from Apple. Key headline announcements like Apple Intelligence rightfully took the media's attention. But there's always a lot of great announcements every DubDub that can slip slightly under the radar. And one of those announcements from WWDC 2024 that might have gone slightly under the radar was Swift testing, the focus of this talk today. So the big question is then, what is Swift testing? Well, Swift testing is a brand new framework or a new set of tools which allows us to create unit tests to make sure our code is doing what we think it is. The big benefit here is that it's super Swifty. If you know Swift, you're going to get up and running very quickly with Swift testing. Whilst there's still a bit of a learning curve, in my opinion, it's a significantly shallower learning curve compared to other testing frameworks. Swift testing is also open source, meaning its evolution as a framework is out there in the open. And that's always a great thing. When it comes to getting up and running with Swift testing, there's 4 main components that you need to know about. These are test functions, working with expect and require, traits, and suites. And the best way to see what these are is by getting our hands dirty. So let's implement some tests. To do this, we're going to add some tests to a fictional code base from Fake App. This is the code base of Splurge, a fictional shopping app. In the code base, there's functions to handle every part of the user's shopping experience. Today's focus will be on a class called Checkout. Here we have a function which takes the amount of funds the user currently has, the total cost of items they want to buy, and it will figure out how much money the user would have left after the purchase. This function is purposely very simple to let us focus on Swift testing. But of course, in the real world, a function like this might have a huge bunch of complex logic in there. But it'll be all right. We just throw it in a tech debt pile or something. It'll be all right. So we want to add a test where we can give this function the 2 values that it needs and make sure the expected value, make sure the return value is what we expect. To add our test, the first thing that we have to do is set up a brand new test target. That means these tests live in a separate area of our project, which won't be included when we ship our app to the App Store. To do this, we head to the general area of our project, we find our list of targets over there on the left, and we head down to the Add button, that one right there. We can then add a brand new unit test target, and we'll give it a name and make sure the testing system is Swift testing. We'll then have a new target in our project, which will come with a new group and a testing file. If we were to jump into the new Splurge test file that was created for us, we'd see the base of a new test set up and ready to go for us. But to really break this down and to really learn what it's doing, let's clear that out and add it all in again. So what do we need to add to this file to create the tests? Well, we need to start by importing testing, the Swift testing framework, which will provide all the tools that you need and everything that we need for this talk. We also need to import the actual target of our actual app, in this case, Splurge. As our tests live in a different target, this file doesn't have access to any of the code in our app target. That means this file has no idea of any of the code that makes your app work. And we kind of need that access in order to get that code to test it. So we'll import it. This works the same way as any other import. Any object, property, or functions marked as public are now accessible. The issue is, for testing, we usually want to go a little bit further than that. By marking this as a testable import, we now have access to all objects, properties, and functions which are also internal, which they are by default. We still won't have access to anything marked as private though. Once we have these, we can create our first test. We wanted to test that the user's funds were correct after their purchase, using that function we looked at just a moment ago. And at its core, this test is just a function. We give it the func keyword, we give it a name, we give it some brackets. It's just a function. We do have to add a little something extra though to tell Xcode that this is a test function. This is the test macro. Xcode will now know that this is a test function. And this test macro holds some superpowers, but more on that a little bit later. For our actual test function, what do we want to do? Well, we want to create a brand new checkout object, and we use the function to calculate those remaining funds. Honestly, this is the exact same as if we were actually just using this function in our code. This means we're calling the calculate available funds after purchase function, telling it the user has 100 available funds and the cost of their items is 75. We're setting the value that is returned from this function to remaining funds. If all's gone well, then the remaining funds should be set to 25. But how do we check that? This is where expect comes into play. Expect is a macro which we can pass an expression to. If that expression is true, the test passes. If not, the test will fail. So in this case, we can say we expect remaining funds to equal 25. We can pass a range of expressions into expect. Effectively, any sort of check you would use as part of an if statement, for example, would work here. Once this is in place, we have our first test, and we can run that test to make sure the value is correct. To do this, we have a few routes. One way to run our test is to tap on that diamond, that one there, just next to our test. The test will run, and if that expression is true, then we get that glorious green tick, and it's kind of big old ugly grey one, showing that our test has passed. We also get this green tick over in the test navigator in the left panel in Xcode. From here, we can run individual tests, groups of tests, or all of our tests. Sorry. We can now be super sure that the logic in our function is going to work as expected. We can then run this test again when we do any work in the area, or before we do any builds to make sure everything is still okay. That means if we go back to this function and break something, our test will tell us. In this case, if we somehow take our return statement and change this minus to the plus sign with the massive overkill transition there, when we run this test again, remaining funds is no longer 25. So the test will fail and we get that big old red cross. It even tells us what the incorrect value is. It tells us, hey, this value is 175, not 25. It catches our issue way before it's anywhere near the App Store. This is a good start, but as our codebase grows and our tests get a bit more complex, we may have multiple things that we want to check per test. Say, for example, the logic we're testing also has an impact on some other really important property in that class that we need to check. Well, we can have multiple expects in one test. For a test to pass, all expects need to pass. One really important thing to note is that if an expect fails, the rest of the test and other expects will still run. So if it fails, the rest will still run in that test. Here we can see that our first expect fails, but the test will continue. In this case, the second expect also fails as well. This is a really important detail to note, as this is a very similar tool, as there is a very similar tool to expect that works slightly differently. This is require. Require works in a similar way to expect. we still pass an expression that should be true. But if the expression is false, the test will stop. To see this in action, consider this. We add a require to our test passing in an expression. Note how we have to mark this with try and therefore say this function can throw. In this test, all three checks, the require and the two expressions, should all fail. However, when the require fails, the test stops. We use this for our critical checks. We use this when we want to say if this expression is false, something's gone so wrong, it's not worth running the rest of the test. So we just stop there. This is a small but incredibly important difference between expect and require to remember. But with the basics of expect and require now under our belt, we're in a good place to get up and going with our tests. But with Swift testing, we can do so much more, and it doesn't stop there. We can do some really awesome things with our tests. Remember how earlier I mentioned the test macro holds some superpowers? Well, it's time to explore them. You see, this test macro is not just a way to mark a function as a test function, and it's actually really powerful, as it allows us to give our tests traits. This allows us to impact how our tests are run, what they do, and how they are organized. There's quite a few traits, but let's take a look at a few that I think are particularly useful. To start with, we can provide a description for our test. This is a string, so we can use spaces and any formatting that we want. This makes it super easy to see what the test does. This description is also used over in the test navigator rather than the actual function name. This looks like a basic and minor win, but this is awesome. When you start creating advanced tests with very particular setups and edge cases, your test function names start to get really long and really complicated. And as the actual function name can't have spaces and we use lower camel case, it can be a real pain to read test function names to really understand what's going on. Like I said, this sounds small, but trust me, when you need to read something long in lower camel case, it can be kind of hard to read. Thankfully, that's not an issue here, as we can use human readable descriptions for our test now like this. See what I mean? So having those readable names can really help, but traits can go so much further than this. And the one that I think is the most powerful is for passing in arguments into our test. Currently, this test has three values: the user starting funds, which is 100, the total cost of the items, which is 75, and our expected result, which is 25. But with traits, we can break these values out of the function. We do this by adding parameters to our function, representing the values that we need. These are then used in the test function itself rather than those hard-coded values. We can then pass these values to our test via the arguments trait. The 100 that's passed in represents the user's funds, the 75 is the total cost, 25 is the expected result. These values are then used in the tests. Know how arguments is an array. That means we can provide a list of arguments, each a tuple of 3 values to pass in. When we run this test, it will now run 3 times, once per set of data in the array. We can quickly, cleanly, and easily run a bunch of different versions of this test with different data. To make this even better, the test navigator shows each of these arguments as if they were their own test, letting us rerun one argument or seeing what has failed. And whilst that is only 2 of the possible traits, hopefully you can see how powerful traits can be. There's a dub video breaking down the traits which I'll point you at the end of this talk. This takes us on to our final component of Swift testing: suites. Suites are a great way to collect our tests together. You may have noticed that our test function isn't in an object. It's just floating out there by itself. In Swift testing, if we want to, we can do that, which is actually kind of cool. But if we have a range of tests all related to the same area of our code base, we ideally want to group them together. We can do this by wrapping our test in an object, any kind that you fancy. By default, simply doing this will make a brand new suite. But we can be explicit and mark this object as a suite using that macro. This suite macro also has traits available which can impact the suite. As this is an object, we can treat it as nearly got there without any bits there. As this is an object, we can treat it like it was any other object in Swift. We can give it properties, we can initialize them, and we can use it in our functions. This is great for properties that will be used in all of the tests within a suite. We can set that property up once rather than having to do all that hard work in each and every test. Say, for example, all tests here would need to use a user object. We set it up in our initializer and each test can then use it, rather than that logic being in each of those tests. There's one really important thing to remember here. The entire suite is recreated at the start of each test within that suite. That means no properties are carried over between tests. Once this suite is set up, we can then run all the tests in this suite together from our code by tapping the diamond next to the suite macro or over in the test navigator. With that, we've now set up our first basic suite. Now that we know the basics of suites, we're in a good position to get up and running with Swift testing. To recap, we've taken a look at what Swift testing is, how to run our first test, expect and require, traits, and suites. This was obviously only a quick introduction, but if you want to see more, WWDC 2024 has 2 great videos on Swift testing, so go check those out. And that is my talk, Green Ticks, an introduction to Swift testing. Thank you.